Addition and subtraction of surds, similar surds. Similar surds are surds which are multiples of the same surd. 2 root 2, 3 root 2, 7 root 2, and 9 root 2 are similar surds because each of the surds is a multiple of root 2. Now, when we talk about multiple or multiples of a given number, it means that particular number multiplying your counting numbers or multiplying the counting numbers. So if we want to get the multiples of 2, we want to, that means 2 multiplied by the counting numbers, which is from 1 onwards, 2 times 1, 2 times 2, 2 times 3, 2 times 4, and on. So 2 times 1 is 2, 2 times 2 is 4, 2 times 2 is 6, 2 times 4 8. No. Yeah. So 2, 4, 6, 8 are multiples of 2. So that's what it means. So what we have here is same thing. So you can see that where we have 2, 2, 2, we have root 2, root 2, root 2. So 2, 3, 7 are simply multiples of root 2. So that's what we mean by multiples of a surd. Then what we discover is that 2 root 2, 3 root 2, 7 root 2, and 9 root 2 are similar surds. Why? Because each of them have the same surd, which is root 2, which is the multiple, the multiple root 2. So also root 8, root 18, root 32, root 50, root 72 are also similar surds, since each of them in their basic forms can be written as a multiple of root 2 as follows. So root 8 in its basic form is 2 root 2. Root 18 in its basic form is 3 root 2. Root 32 in its basic form is 4 root 2. Root 50 in its basic form is 5 root 2. Root 72 in its basic form is 6 root 2. So what you discover is that these surds in their basic form are simply multiples of the same surd, which is root 2. So in this way, they are all similar because they are all similar because they have root 2 as the multiple or as a similar surd. So two similar surds can be added or subtracted from each other. In the last class, or no, the first lesson under surds, we looked at the rules of surd, where I said root A plus root B will simply be equal to root A plus root B. Same way, root A minus root B simply equal to root A minus root B. The reason is that once the surds are not the same, the letters, here we are using letters, but when we start calculating, we are not going to be using letters, we're going to be using figures or numbers. So when the letters or numbers are not the same, we cannot add because they are not the same. That's just the reason. So root A plus root B, since the letters under the square root signs are not the same, we simply equate them. So root A plus root B is equal to root A plus root B, and root A minus root B is equal to root A minus root B. This also follows the case if it were algebra. So if you have A plus B, simple algebra, or 2A plus B, you know this is just the same thing as A plus B or 2A plus B because they are unlike terms. So you can't do anything further. You just have to leave it like this. But if, let's say, instead of A plus B, what if it was A plus A? Of course, since the terms are the same, A and A, then you can add that. And A means 1A plus 1A, but whenever it is algebra and also in surd, when anything is A or 1A, you don't write the 1. It's omitted in maths. So you simply write A. But from 2 upwards, you can write it. So you have 2A, you have 3A, you can have 4C, you can have 8X. But once it's just the coefficient is 1, you don't write it. Just write the letter or the variable. So A plus A is 2A. This is when the terms are the same. So same rule applies to surds. If the terms or the roots are the same, like root A plus root A, then addition is possible. So this becomes 1 root A plus 1 root A. This will give us 2 root A. So if here were 2 root A plus 3 root A, then this will become 2 root A plus 3 root A. This will give us 2 plus 3 root a, and that will give us 5 root a. Similarly, if it were subtraction, this will give us just as we have 2a minus a to give us a. So 2 root a minus root a will give us root a. That's 2 minus 1, then root a. So this tells us that two similar surds can be added or subtracted from each other, and that is when the surds are similar, like root a, root a. So we have similar surds in this case, similar surds in this case, similar surds in this case. But when the surds are not similar, like root a plus root b, these are dissimilar surds. We can't add and we can't subtract, so we just have to equate it. Yes, just as what we have equates to what's that's what we have here. That's what's going to happen on the other side of the equation. Now, okay, let's take our notes. Two or more surds can be added together or subtracted from one another if they are like surds. So, like and similar, those are the two things you need to take note of. They must be like or similar. So, like means just like terms and unlike terms. So these are like terms and these are unlike terms. Okay, these are like terms, these are unlike. A and B are unlike. The two letters are not the same. But when the letters are the same, we say they are like terms or similar terms. So addition and subtraction, both in algebra and in surd, is possible when the letters or the surds are the same, like or similar. But in a situation where they are not the same or alike, you can't carry out addition and subtraction. So, but before addition or subtraction, the surds should first be simplified if possible. The examples I'm going to take subsequently will show cases where before addition or subtraction is carried out, there must be simplification carried out first. So let's go on. So number 1, or A, 4 root 2 plus 6 root 2. So the condition must be met if we must be able to add these two surds, and that condition is that both surds must be similar or alike. So in this case they are. So this will give us 4 root 2 plus 6 root 2 give us 4 plus 2 root 2. 4 plus 2 is 6, and give us 6 root 2. 6 root 2. That's A. B. 3 root 5. 3 root 5 minus 7 root 5. So since the roots are the same, we can subtract. So 3 minus 7 root 5. And this will give us 3 minus 7 is equal to minus 4 root 5. 3 root 8 plus root 50. You can see, merely looking at it, it looks as if addition will not be possible. Well, that might have been the case if we try to add these two surds without simplifying it further. For what we can see, we can simplify this surd. So if we simplify it further and we discover that the simplest form we can get to, both surds are not alike, then we may not be able to add. But if both surds are alike, then we can add. So let's simplify further. So this will give us equal to 3 times root 8 plus root 50. So let's go. Let's go to 3 times root 4 times 2 plus root 25 times 2. Okay, so this will give us 3 times root 4 times root 2 plus root 25 times root 2. 3 times root 4 is 2 times root 2 plus root 25 is equal to 5 times root 2 3 times 2 is 6. 6 times root 2 will give us 6 root 2 plus 5 times root 2 is 5 root 2. Now this is the simplest this solve can get to. So at this point you can see that both solves are alike, they are similar, so we can add. So give us 6 plus 5 root 2, and then 6 plus 5 is 11 root 2. That's the answer. D 2 root 27 plus root 75 minus 5 root 12. Minus 5 root 12. So what we're going to do is exactly what we did here, because if we are to add in this form, it will not be possible because the solves are not alike, but we can simplify it. So because we're going to simplify it and we want the solves to be alike, we must be careful with the factors we are going to use. So this will give us 2 roots 9 times 3 will give us 27. So plus, so I'm going to use a factor here that the surd will also be the surd that we are not going to get the square root of will also be 3. So here we will give us 75 will give me 25 times 3. So I think I have 3 here, so I have 3 here, so 25 times 3, and then minus 5 root 4 times 3. So I have 3 here, I have 3, I have 3 here. Okay, so let's proceed. So 2 times root 9 times root 3 plus 2 times root 25 times root 3 minus 5 times root 4 times root 3. This is equal to 2 times root 9 is 3 times root 3 is a surd. The value will not give us an exact answer, or the value will not have an ending, so I'm going to leave it as root 3. I won't get the value since I can get the exact value for root 9. So, and the rule is that if one of the factors is a perfect square, you will be able to get the square root of that perfect square. So that's what we got to from root 9. And then let's move to this point. Root 25 is 5. 2 times 5 times root 3, then minus root 4 is 2, so that gives 5 times 2 times root 3. Let's go on. 2 times 3 is 6 root 3. 2 times 5 is 10 root 3. And 5 times 2 is also 10 root 3 plus 10 root 3. Here's root 75. There's no 2 here, so I'm not supposed to have 2 here. There's not supposed to have 2. And it's not supposed to be 2 also. So I'm not supposed to have 2. We also have 5 root 3, so here's 5 root 3 only. And so 25, so here's 5 root 3. And 5 times root 3, 25 root 3. Okay, so this 5 root 3. So now let's add, here's minus. So this is equal to 6. 6 plus 5 is 11. 11 root 3 minus 10 root 3. And 11 root 3 minus 10 root 3 is root 3. Like I explained earlier, 11 root 3 minus 10 root 3 is 1 root 3, but in maths, we don't write 1. So, especially when it's before another value or a letter. So, if you have 1a, you simply write a. If you have 1b, you simply write it as b. But if you have 2a, you can write 2a. If it's b, 3c, you can write it. But if it's 1a, you don't write it. You just write the later. Same thing with the surd. So instead of writing 1 root 3, we just have to write root 3 as a final answer. Root 20 plus root 45 plus root 125 minus 2 root 80. This will give us root 4 times 5 plus root 9 times 5 plus root 25 times 5 minus 2 times root 16 times 5. Okay, so this will give us root 4 times root 5 plus root 9 times root 5 plus root 25 times root 5 minus 2 times root 16 times root 5. And this will give us root 4 is equal to 2. 2 times root 5 equals to root 5. So root 5. Root 9 is plus, that's 3 root 5. And here plus 5 root 5 plus 5 root 5. And then here minus root 16 is 4 times 4 is 8. 8 root 5. So since they are similar, we're going to add. So let's add up the positive side first. 2 plus 2 is 5, 5 plus 5, 10. Equal to 10 root 5 minus 8 root 5. 10 minus 8 is 2, so that's plus 2 root 5. 3 root 2, 3 root 2 minus root 32 minus root 32 plus root 50 plus root 98. So that will give us 3. To make it simple, since we already have root 2 here and we need to add or subtract, that means we must ensure that the sort that will be similar all through will be root 2. So we're going to make everything here to be a multiple of root 2. So since it's a root 2, so it's 3 root 2 minus 32 will give us 16 times 2 plus root 25 times 2 plus root 49 times 2. This will give us 3 root 2 minus root 16 times root 2 plus root 25 times root 2 plus root 49 times root 2. 3 root 2 minus root 16 is 4 root 2 plus 25 is 5 root 2. 49 is 7 root 2. So 3 root 2 minus 4. Okay, minus 4 root 2. This part is negative, so I'm going to add up the positive side first. So this will give me 3 root 2. I'm going to write it 3 root 2 plus 5 root 2 plus 7 root 2 minus 4 root 2. So what I did was, or what I've just done is, I have to rewrite this expression again. I have to bring all the positive, the terms that are positive to one side and the term that is negative to the other side, which is minus 4 root 2. And then every other term is positive. So let me start with the positive terms. 3 plus 5, 8, 8 plus 7 will give me 15. So that will give me 15 root 2 minus 4 root 2. So 15 minus 4, that's 15 minus 4 root 2. 15 minus 4 will give me 15 minus 4 will give me 11 root 2. 6 plus root 27 plus root 75. So this will give us 6 plus this one does not have roots, so we can't manufacture or we can't fabricate roots for it, so it's going to remain like this. So let's simplify this in a basic form. So this gives 27, 9 times 3, 9 times 3 plus 75. This will give us 25 times 3, root 25 times 3. And this will give us 6 plus root 9 times root 3 plus root 25 times root 3. And this will give us 6 plus root 9 is 3 root 3 plus root 25 is 5 root 3. So we're going to add, this will give us, this is equal to 6 plus 3, 3 plus 5 plus 5 is 3, and that is 6 plus 3 plus 5 is 8 root 3, and that's our final answer. Okay. 224 minus 126 minus root 56. This will give us root 16 times 14 minus 9 times 14 minus 4 times 14. And this will give us root 16 times root 14 minus root 9 times root 14 minus root 4 times root 14. Root 16 is 4. 4 times root 14 is 4 root 14 minus root 9 is 3. 3 times root 14 is root 14. Root 4 is 2 root 14. So this will give us 4 minus 3 minus 2, or multiplied by root 14. This will give us 4 minus 3 is 1. 1 minus 2 will give us minus 1. And since it's 1, we're not going to write that, will give us minus root 14. So final answer.